Hello everyone. In this video, today we will talk about how to do the design, truss design. All right. So here I have take one questions. The questions ask us if I read for you that the figure below shows a truss. Yes, it's a truss with tension and compression members carry maximum force 0.94 and 8.3 kilonewton respectively. So that's mean in here we can understand already that tension force is 9.4 and the compression members force is 8.3 kilonewton. So design for the both tension and compression members using steel grade S275. So we use the grade S20 275, and already here one section size already given. So the section size is 50 times 50 times 5 SHS. So we can get the related value from the Eurocode. So length of the truss is 1335 millimeter. So this is the length. So the length is 1335 millimeter. Assume that 20-meter diameter bolts in 2 millimeter clearance holes. So this is the question. So the first things we will do that we will list down all the informations that is already available from the questions. All right, so let me write the questions, I mean the list down the informations that already available in the questions. So okay, so we have the NED for the tension is 9.4 kilonewton. Okay, we already get it from the questions. Okay, and the tension 8.3 kilonewton is compression. All right. Okay, so after that we know the size that questions ask us to try. So our try section is B times H times T equal 50 times 50 times 5. All right, so now what we have to do, we know that H equal B and H equal B equal the 50 millimeter, because the same value we can get it. So then T equal 5 meter. T is the thickness. All right, and the IZ is the value for the radius of gyrations. Okay, for the radius of gyration. So if I see the value, so I get the IZ is 18.2 millimeter. So you get this value from Eurocode 3. So one things I forget to mention is that we are designing the truss based on the Eurocodes. So and for the steel structure we know that we use the Eurocode 3. So let's back to the question. Okay, so A is 873 millimeter square that we get based on the size, okay, from the Eurocode. All right, so I already list down all the informations that already are available in the questions. So now my first step will be, okay, my first step materials properties. Okay, so for the materials properties, we know we have the E value is 2111, okay, Newton per millimeter square. Okay, then okay, now after that we know the thickness. So thickness is 5 meter, so 5 millimeter, which is less than 16 millimeter. So that's why our Fy is 275 Newton per millimeter square. So epsilon, we know the formula that root over 235 divided Fy, sorry, root. Okay, now I just plug the value in the equation. So 275, so I will get 0.92. all right, so based on there we know that C equal 50 minus, okay, 2 times 5, so I will get 40 millimeter. So C by T, we get it, C is a 40, just I find out, yes, 40, so that's why I take 40 over T. T is the thickness, which is 8, so my thickness is 5, okay, this is my thickness 5, yes, 5 millimeter, so that's why I take here, so we will get 8 millimeter. So for the class 1 limit, we will get this value from the table, okay, so 33 epsilon, so 33 times 0 0.92, we will get 13.36, which is more than 8, that the value that we already got from here. So we can say that our section class is 1. Okay, so the first things we will solve about the materials properties, okay, until here. After that we will follow the classification, okay. So once we finish the classification, we will move to the second step, and second step we will find out the compression, okay. We will check the compression of the cross section, okay. So the first things, NCRD equal AFY over gamma naught. So we know the A is the area 873 times Fy is 275 times, we are going to convert the Newton to kilonewton, so I just multiply with 10 power negative 3, and I will use the value of partial factor, which is 1. So if I plug in all the value into the equation, so I will get, let me do the calculation, okay, 873 times 275 times 10 power negative 3, okay, so over 1 we will get 240 kilonewton. Now NED over NCRD, so our NED is 8.3 and 240 my NCRD, so which should be less than 1. So if I do the calculation, I will get 0.034. That's mean for the compressive design resistance is adequate or satisfied, so no problem with the classification size, right? Okay, now we will move to the, okay, so if we need to calculate the flexural, okay, buckling, okay, so we know the formula x equal 1 over phi plus phi square minus lambda square, okay. So in here we will get the phi, we get phi, how is the formula, 0.5 1 plus alpha lambda minus 0.2 plus lambda square. So I just write the formula. So what we can get in here, alpha is 0.21. Why this 0.21? Because we get it from Eurocode 3. All right, we use the Eurocode 3. Okay, after doing that, so we have the LCR is 1.0 L, so 1.0, what is the length? So we get the length 1335, where we get it 1335 from the questions. Yes, already it's given length of the truss. Okay, so now we will get 1335. After that we have to find out the lambda 1. So what is the formula for lambda 1? We know Iz. Why I'm taking the Iz? Because Iz is the smallest value for radiation of gyration times 1 over lambda 1. So okay, so LCR we already got the value, just we'll plug the value into the equation. 1335 over Iz, already we got 18.2 from the Eurocode table. Okay, so you can get it from there, and 1 by lambda 1. So we know the lambda 1 value will be 86.39, because why? Because the lambda 1 equal 99. Okay, so 99 times 0.92, we will get 0.2 multiply, and we will get the 86.39. so it will be the lambda. Okay, lambda bar. So once we get it, so now we will just plug in all those value that we just get it from here. So I will get it 0.85. so now phi equals 0.5, 1 plus alpha lambda 0.2 plus lambda bar square. Okay, so 0.5, 1 plus, so alpha we know already, so 0.21 we got from the curve diagram. Okay, so lambda just lambda bar we get 0.85, 0.85 minus 0.2 plus 0.85 square. Okay, let me do the calculation. Okay, so my value will be 0.93. so this is the phi value. So now we need the x value. So what is the formula for the x? Okay, phi plus square root phi square lambda square, and which will be less than 1. Okay, so 1 over, so our phi is 0.93. I just plug in all those value into the equation. 0.93 square minus lambda, so lambda is 0.85 square. If I do the calculation, all those value if I put into my equation, so I will get 0.76, and which is less than 1. So that's mean the design flexure buckling resistance of provided 50 and times 5 is satisfied. Okay.